Okay, so how do we obtain the inverse sine function? Same idea here. What I did was I graphed from negative 2 pi to 2 pi, and I took a look here, and clearly we passed the vertical line test. This is f of x is equal to the sine of x. You pass the vertical line test, but we do not pass the horizontal line test as is. So as stated before, what we're going to do is we're going to restrict the domain. And what you really want to do is focus on where is or where are all y values represented. So when you're talking about positive or negative y values, what they did was they restricted from negative pi over 2 to pi over 2. And what this is here is quadrant 4 from here to here, which is where my y values are negative, and from here to here, where my y values are positive. So what I did was right here, this is still the sine of x, but now based on a restricted domain. So I took this portion of the graph and I blew it up from negative pi over 2 to pi over 2. So this is quadrant 4, this is quadrant 1. So now this passes the vertical line test and the horizontal line test. So now that we pass with the domain restriction from negative pi over 2 to pi over 2, we can now identify the inverse. So basically what happens here is your x values now become your y values, and your y values become your x values. So this is the inverse. Okay, which will be written as a couple different ways. You've got either the inverse sine of x, or you could see it as the arc sine. Okay, so these are two common ways that you would see the inverse of sine. All right, so what does this mean? Your domain for the sine of x is all real numbers. This is for the original. The range goes from negative 1 to 1. So remember, everything is going to switch. So a good domain restriction on the function we decided or looked at is negative pi over 2 to pi over 2. So now remember, everything is going to switch. So take a look here. What we had to do is we had to restrict the domain. So now this belongs here, which will then become my range. So the range is negative pi over 2 to pi over 2. And the domain is from my original's range, which is negative 1 to 1. This is important. Okay, when we're talking about the inverse sine, you will need to know these values. Okay, now remember the composite for the inverse sine. Here, if we know our original is the sine of x, and this is the arc sine, you've got the sine, arc sine, or inverse sine of x, okay, which is the same thing as the sine, arc sine of x. This should be equal to x, but this is the biggest thing, okay? You have to make sure you know what your restriction on x is, okay? And here, it's negative 1 to 1. So that value must fall between negative 1 and 1. Okay? Let's take a look here. Now we've got the arc, or the inverse of the original. So it's going to be the arc sine of the sine of x, okay, which is equal to arc sine of the sine of x is equal to x. Now here, when your inverse is on the outside, you have to use your restriction for the range. Okay, so here, that's why I'm color coding. This has to be the original, which is negative pi over 2 to pi over 2. Okay, so when your inverse is on the outside, okay, this is going to be your range's restriction. When your original is on the outside, it is the range restriction for the original. Take a look. Okay. Now, what does this mean? If y is equal to the arc sine of x, This actually means that x is equal to the sine of y, where your x values are falling between -1 and 1, and your y values between -pi/2 and pi/2.